let's continue. Okay, so this is lecture 2b, is a continuation of lecture 2a, Cartesian coordinate, or you can call rectangular coordinates. You see, those are particular cases. Okay, particular case of what? General curvilinear coordinates. You see, that's this is a strong support for you to understand how to you solve the properties, you present the properties about curvilinear coordinates in general. See, so this is Cartesian coordinates, rectangular coordinates. Then you're going to talk about cylindrical coordinates, and then spherical coordinates. So I guarantee you that you'll be prepared to face this new subject about generalized coordinates. Okay, that will be helpful just to develop all classical mechanics, you see, as well as general theory of relativity. Okay, that's a basic concept. Now, from lecture 2a, okay, Cartesian coordinates, that's a continuation. Okay, you wrote that the position vector is xi ey, I is dummy index, okay, and ei dot ej is delta ij, orthonormal base vectors. Now, you see here, that's a position vector, and you see this vector over here, okay, is x2 e2. This one is x1 u1, and this one is x3 e3. So if you add, let's call x1 x2 as a floor, okay? This is a floor. Now, you see, if I sum this vector here with this vector here, I obtain the vector OQ. You see? So, OQ plus x3 e3, this leads to the position vector A. You see, I just wrote here, I would like to emphasize that this part over here, this is equal OQ. You see? OQ, you see, is x1 u1 plus x2 e2. Okay? That's, I will put better here. Okay, I'll do like that. You see, this is OQ. Okay, so OQ plus x3 e3 is just lead to the position vector R. It's quite simple. Now, you see, the base vector, the Cartesian base vector, or the rectangular base vector, is constant, okay? Because when you move from one point to another point, you see, these bases, E1, E2, and E3 doesn't change, you see, doesn't change. So it's constant. That's why partial derivative of EI with respect to xj, this is equal 0, okay? Xj could be x1, x2, or x3. EI could be 1, 2, 3, or 1, 2, 3. This is B, vector 0. Okay, so it's constant. Now, you see, differential of the position vector. R. You see? So, not from calculus, okay? R is a function of x1, x2, x3. So, dr, you see the differential of dr is equal partial r with respect to x1 dx1 plus partial of r with respect to x2 dx2 plus partial of r with respect to x3 dx3. Look, on the other hand, you can see clearly that x, you see here, x is equal x1 u1 plus x2 e2 plus x3 e3. Now, I'll write here, okay, x is equal x1 e1 plus x2 e2 plus x3 v3. You see, it's just the sum, okay, here. I is equal 1, 2, 3. Now, you see, e1, e2, and e3, they are constant. So, dr, okay, will be, now, I have, this is constant. So, this is a product, but e1 is constant. So, then I'll have here the x1 e1, because e1 is constant. The differential here is reach only the x1 plus the x. I'll write like this. Okay, I'll change the order. Okay, that's it. That same result. Okay, then I'll write here e1 the x1 plus e2 the x2 plus e3 the x3. Now, let's this expression like 1 and 2. Look how interesting. Comparing 1 and 2 yields. You see? Look at here. I'll put some color here. Okay? Look this one, dx1, and look this one. See? You look this one, and look this one. You see? Likewise, this one here. You look like this. So, comparing, you conclude that attention now, this is a very, very, very important. This will be applied when you will study the generalized coordinates. Don't forget this. You see, look, I can say that comparing here, partial r with respect to x1 is equal E1. Partial r with respect to x2 is equal E2. And partial r with respect to x3 is E3. This is a very, 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 very important result here. Okay? Very important. Because I will use this in cylindrical coordinates, I use this in spherical coordinates, and also in the generalized coordinates. Okay? Any curve, okay, that will be a coordinate, general coordinate, any curve. Okay? That's why I'm insisting in saying that cylindrical and spherical, they are curvilinear coordinates, but they're special, that's particular. Okay? Then that's a very, very important. See? And now, later, okay, next videos, I'm gonna derive the cylindrical coordinates, okay? And then that's it. That's a Cartesian coordinates. You see, those subjects is just to give you an idea that